Okay, welcome back and good evening. Okay, so we're almost finishing up the second third of the class. So we're just about 2/3 of the way done, starting next week. So we're gonna do today we're gonna do kind of a review session slash practice exam for midterm 2, just kind of like we did for midterm 1. So hopefully that helps you prepare for the exam. And so okay, so the chapter 16 homework is due today, so I'll see if there's any questions on that. And again, tonight in today's session, we'll go through a practice exam for the midterm 2, and then after we're done with that, I'll post the midterm 2, which I'll be doing a week via email, just kind of like the first exam. And then I even have a kind of some extra credit questions that go with the midterm 2, and so we'll get to that as well. All right, so all right, so it looks like at the moment only 2 students have submitted chapter 16 homework. Now it's not due till the end of today, but is everyone okay on the chapter 16 homework? Are there any questions on that? Can I go over part D? Sure. Okay, so the limits of the terms of trade. So this is where, so this one is where you got to specify each good that the respective country or economy is going to specialize in, and then what they're getting from the trade, and then you kind of flip it around to make sure that when they trade for the other good, they're getting a better deal than just producing it in house, I guess. So all right, so you probably got, or you probably figured that Cuba was going to specialize in cigars, and Kentucky was going to specialize in bourbon, right? So that had to be worked out, but that's what you should have gotten. Okay, so knowing that Cuba has a competitive advantage in cigars, they're going to produce only cigars and then get their bourbon via trade. All right, start with Cuba, who's going to produce cigars, and so that means that before any trade, they could have traded. They could have traded one cigar for a fourth of a bourbon, right? And so they're giving up a fourth of a bourbon pretty much every time they produce cigars. So that was their domestic opportunity cost, and so that means their, I guess, international opportunity cost, their trade. If they beforehand they could trade one cigar, for a quarter of a bourbon, they got to get more than that. So they now have to get at least a quarter of a bourbon and preferably more. So their return has to be one cigar is better than a quarter of a bourbon. Okay, so there's that right there. This is just saying so Cuba start with the good they're specializing in, then start with their domestic exchange rate, and go from there. So we'll modify them on the same term in a minute. Let's start with that. So Cuba specializing in cigars, and therefore in the trade they got to get better than their domestic opportunity costs, which is one cigar is equal to negative 1/4 bourbon. All right. Now let's do Kentucky's. All right, so we figured out, or we should have figured out, that Kentucky has a competitive advantage in producing bourbon, and they're going to produce only bourbon, and any cigars they get will get them in a trade. Okay, so start with their domestic specialized good and the domestic opportunity cost for Kentucky, which is one bourbon equals negative 1/2 cigars. So that's what they got already, and that's that's their domestic opportunity cost. So that means that in a trade, they got to get more than that. They got to get at least half a cigar when they trade a bourbon, because right now when they give up a bourbon, they're giving up just half a cigar. So they got to beat this. All right, so I just restated those domestic exchange rates there with the good that each economy is going to specialize in. Okay, so Kentucky is going to specialize in bourbon. And that means that when they trade bourbon, they got to beat their domestic opportunity cost, which is one bourbon equals negative 1/2 cigars. So that's the statement here. Kentucky needs to get more than one bourbon equals negative 1/2 cigars. Okay. Now Cuba is going to specialize in cigars, and that means that in a trade they got to beat their domestic opportunity cost, which was one cigar equals negative 1/4 bourbons in a trade. So Cuba's got to get more than that. So Cuba's got to get more than one cigar equals negative 1/4 bourbon in a trade. Okay? So those statements we already figured out in part B. Okay, now the limits are just rearranging these statements to put them on the same terms. Like, here, we see how we have one bourbon equals this and one cigar equals this. We got to put it in terms of, it doesn't really matter which one you do it, but you got to put it this in terms of one bourbon equals, and this in terms of one bourbon equals, or this in terms of one cigar equals, and this in terms of one cigar equals. Okay, it looks like I did it in terms of cigars. Okay, so Cuba's is already in terms of one cigar equals. So put that here. One cigar equals negative 1/4 bourbon. Now, how do you represent this statement in terms of cigars? Okay, just multiply both sides by 2, and that'll say one cigar is equal to negative 2 bourbons. Okay, so I wrote the statement for Kentucky in their original domestic opportunity cost for the good they're going to specialize in. I wrote the statement for Cuba in their original domestic opportunity cost with the good they're going to specialize in, and then I put them on the same terms, which in this case is one cigar equals, and then one cigar equals. So this statement is already in one cigar equals. And to get this into terms to one cigar equals, just multiply by 2, and you get one cigar equals minus 2 bourbon. So now they're both in the same term, and so therefore the trade that's going to benefit them both has got to be in between this. So any cigar trade for one cigar equals one bourbon, or one cigar equals 1.5 bourbon, or something, anything in between this, the limits, is correct. And you could have also put it in terms of one bourbon equals. So another way to express the limits, if you did it like this, is I'll just Okay, so this one is already in one bourbon equals, and to put this one in terms of one bourbon equals, multiply both sides by 4. That gives us one bourbon equals minus 4 cigars. Okay, so the point is you can express the limits as like this, the one cigar equals, or in terms of bourbon, right? So you got to get them on the same term so they know what trade is going to benefit both countries. So again, start with the good that each country is going to specialize in, state their domestic opportunity costs, and then get those on the same terms, and that's going to tell you what trade is going to benefit both. So any trade for one cigar equals something in between this, and any trade one bourbon equals something in between this. They're both the same exact thing, just expressed in a different one unit. But either one of these statements, this one, okay, either one of those statements that I highlighted here is 100% correct. So if you got this or this, then you're correct. Uh, Otherwise, it needs to be fixed. So this is actually the part D is one of the more difficult concepts, but I think we'll do another. We'll have another example today, and then you'll have another one on your midterm. But does that make sense? Is it clear what we're trying to express here for the limits? Okay. All right. So you're welcome. All right. Dominic is good. Everyone else understand this concept? All right. So any other um, parts you want me to take over for the chapter 16 homework? Okay. So I got the answers. I got the my solutions pulled up here. So this is the time to ask. All right. Okay. Well, let's. All right. Well, we're going to do another example, just like this in the practice exam. And so, if anything else comes up on chapter 16 homework, then let me know. But yeah, that's All right, so let's do the review, or let's go over a practice exam for midterm 2. All right, so if you go on Blackboard to the midterm 2 section, you should see a practice exam. And so there's a Word version and a PDF version. Okay, so we'll go through this, and then you can use this as a reference when you do your exam. But you're gonna have 3 big questions. Each question is worth pretty much 33 and a third. All right, so first question is going to be like on the chapter 7, 8, 9 homeworks, where you're going to determine the price, the quantity, and the profit of the firm. And then I also added a third or fourth part for these, where you got to identify the type of market it's in. So it should be pretty clear based on the example and what's going on, which of the 4 types of markets it is. But that's a nice little part, just so you can identify which of the 4 markets you're operating in. Okay, so number 1 will be like that. Number 2. There will be 2 questions on game theory that you'll have to answer. So you'll do one where you do collusion, or no collusion, that you're doing collusion, and then if one of the players cheats. And you'll do another one where you draw the the decision matrix, and do the same thing. And some of these you might reach an agreement, and some of them you might not. But you'll have 2 of those. Okay, and then number 3 will be on the one we just did, the chapter 16 type, where you're going to have the same type of example we did in the homework and in the study guide, and we're going to do now. So you have 3 examples to use to do this, the one that's on your midterm, but same process here. You set up the gains from trade, and you do the whole process there. So 3 big questions for your midterm 2. Okay, so today's plan is I wanted to make sure everyone was good on chapter 16. It seems like that's okay. Then I want to go through this practice exam. Then I wanted to post your midterm, obviously, and then I'm going to post. There's a couple bonus questions that I'll have for extra credit that I kind of made up that go with some of the propositions in California that just were presented. So we'll get to that too. Okay, so let's first go through the practice exam. Okay, so I posted my solutions. Let's go through those. And then I also posted the Excel work I did for some of the questions. So you can use that as a reference as well. All right, so here I did the game theory stuff in Excel, and I did the graphs for the production possibilities curve for chapter 16 here. So you can use this again as an example if you want. Again, these questions you can do in Excel, or you can do just on graphing paper. Whatever you prefer to do is fine with me. All right, so here we go. Here's the practice exam solved. Okay, so the number one question is going to be on it's going to have the title of markets and profit max. All right, so you had four different market types, and you got to identify which one. First, you got to do the profit max, price, quantity, and profit, and then you got to identify what type of market I'm describing. Okay, so the following equation describes a firm's total cost and marginal cost. Here's total cost, 100 plus Q squared. Here's marginal cost, MC equals 2Q. And then part A, if the firm is a price taker and other firms in the industry sell output at a price of 100, what price should the manager of this firm put on the product? So if it's a price taker, it's got to either take the price or not. So the price for a price taker is set by the market, so they're going to set their price at the same price, which is price is 100. Okay, so to get this one, it's not, don't have to do anything. It's just kind of a trick where if they're a price taker, just state the price. All right, so if it says if the firm is a price taker and other firms sell this price, then that's the price you're going to sell at. So price is 100. Okay, and I know I last or when I graded your the homeworks for I think this was chapter 7 and chapter 8 or chapter 8 or chapter 9, whatever it was. Um, these questions, you guys, all of you did really. I mean, I think almost all the homeworks were 100% correct. So it seemed like everyone had a pretty good idea of how to do these. So I'll go through these, but I'm pretty sure that yeah, you guys did really well in the homework questions. So I think you'll do well in the midterm here. Okay, what level of output should be produced to maximize profits? Remember, the profit maximizing rule is always this. Okay, that's the only situation in which below that, quantities below that, you can check and they'll get less profit. Quantities above that, they'll get less profit. So this is the best they can do. So just stick with what you know. With the best option to choose a quantity for any firm is where marginal revenue equals marginal cost. So do that. Okay, you also know if the firm is a price taker, that means they have a perfectly elastic demand curve, right? And if that's the case for this type of market, the price is going to equal the marginal revenue. Okay, so for a price taker, since you have the horizontal demand curve, that means that each additional unit sold is sold at the same price. So on the margin, it's always the same. Okay, so for a price taker, that denotes a perfectly elastic horizontal demand curve. That means that you have to have a situation where MR equals price. So just you have the price. So we'll plug in the fact that we started with this. Okay, we know that price equals MR. So let's just plug in price for MR, which means that price equals marginal cost. All right, and that's the situation you want to start with for a price taker, which means just plug in the price. That's given, that's 100, and plug in the marginal cost, that's given, that's 2Q. All right, here, then just solve for Q, right? Divide both sides by 2, you get Q star is 50. Okay, part C, how much profit will be earned? And you know the profit equation, that's just total revenue minus total cost. Represent total revenue as it's only a one good situation, so the price of that good times how much they sell, price times quantity is total revenue, and then subtract the cost function. Okay, so there's the cost function, minus 100 plus q squared. Then just plug in the price of 100 and the quantity of 50 and see what the profit is. So profit equals price is 100, quantity is 50, minus the fixed cost of 100, and then minus 50 squared. Now, the one problem I did see maybe once or twice on your homeworks is that some of you might have forgot to distribute the minus sign here. So make sure that, see when it's, this whole thing is a cost. So that means it comes out of the profit, right? So you have to subtract this because you have to pay it. Okay, so you have to subtract the 100. That's the fixed cost, and you also have to subtract the q squared because that's the variable cost. So this is minus 100, and then distribute the minus 50 squared. So make sure that this minus sign here gets distributed to this and to this because they're both costs, and you have to pay for those. So those come out of the profit. All right, so I did see that was one common mistake. We're not distributing the minus sign, so make sure that on the exam you carry the minus sign. Okay, and if you simplify, you get 5,000 minus 100 minus 50 squared is 2,500, and this comes out to 2,500 minus 100, which is profit of 2,400. Okay, then this is the part D is going to be identify what type of market it is. So there's 4 types of markets. What type of market is this firm operating in? And this one is pure competition, right? And so why do we know that for this example? So why is this pure competition? What's the key word or the key indicator? Okay, so if you get like kind of the keyword of price taker, and you see that the price is given, and so if you know you're not solving for the price, then this has to be pure competition because all the other markets you get to choose your best price based on demand. So if you see the keyword price taker, and also if there's no marginal revenue function given, that pretty much means that marginal revenue is just equal to price. So the keyword or the indicator for pure competition, which means a perfectly elastic demand curve, is price taker. Okay, and so that's going to identify pure competition. Okay, and you can see the difference. See how all the other examples, all the other types of markets, you'll be given demand, total cost, marginal revenue, and marginal cost. So if you're given these 4 things, it can't be pure competition because marginal revenue changes with quantity. So if you see 4 equations, it's not pure competition. That's what I'm saying. All right. The second part is to do the same process, then identify the different type of market. And it's probably not going to be the same thing. So the following equations describe a firm's demand, marginal revenue, total cost, and marginal cost. Demand equals that. Total cost is that, 100 plus Q squared. Marginal revenue is 100 minus 8Q, and marginal cost is 2Q. Okay, so all these equations will be given. Okay, what level of output should be produced to maximize profit? So again, you start with your profit maximizing rule. Set MR equal to MC, then choose your best quantity. So you're given those things. Right, so just set those equal and then find the best quantity that's associated with that. There's only going to be one. Okay, so MR is 100 minus AQ. Set that equal to marginal cost, which is 2Q, and now just solve for Q. Let's see, let's add 8Q to both sides. We get 10Q equals 100. Divided by 10, we get Q star is 10. Okay, what is the market price? So here, not a price taker, which means that we take the quantity we chose, plug it into the demand curve, and see what the market would pay, and that's our best price. So here's the demand curve. Plug in Q start of 10 into that Q, and then find out what that price is. Okay, 100 minus 4 times 10. Okay, 10 is the Q star. And what's the price? 100 minus 40, which is our best price given a Q of 10 is P star is 60. All right. How much profit will be earned? And same equation. Profit is total revenue minus total cost. It's always going to be a one good situation, so that's just the price of the good times how much you sell of it. That's revenue. And again, subtract the whole cost, which is given 100 plus Q squared. All right. Price is 60. Q is 10. Remember again, distribute the minus sign, minus 100, minus 10 squared. This is 600 minus 100 minus 100, which is 400. Okay, and then you get one little clue here where the firm is a public electricity company. And given that, you should know that what type of market is the firm operating in. So you pretty much know that all utilities, at least all the utilities around here, are operating as monopolies. So if you get any type of utility, like all right, so any utility, electric company, gas, water, trash, these are going to be examples of monopoly, which is what you have here. Okay, so the last statement should give you enough information. It'll give you an example or some key attribute of the market that we're talking about, and there should be a clear indicator of what type of market it is. Okay, so again, there's 4 types. We've already listed 2. Okay, so can we remember what are types 3 and 4? The other options? Okay, so those are all the types of markets we talked about in chapters 7, 8, and 9. So on the question number 1 on your take home midterm 2, the answer is going to be one of those 4 things. Okay. Okay. So any questions on the first question before we move on to number 2? Okay. Number 2, you're going to have two questions on game theory. So here's an example of one of them. So refer to the following payoff matrix for player A and player B. Player A has 2 strategies up and down, whereas player B has 2 strategies left and right. Player A's payouts are listed first and player B's second. All right, so the first part's always going to be assuming no collusion between player A and player B. What is the likely outcome? Just list the strategies and the payouts. So I did this in Excel. All right, so you can use that for an example if you want. Again, you're also welcome just to do it on graphing paper or just with a ruler. Whatever's the easiest way for you to get your answers produced. Okay, so again, to refresh, what you want to do for this part with the no collusion is choose both players' best response to the other player's options. And then with that, you should be able to determine where they'll both agree upon, because either they're both going to choose the same strategy no matter what, or at least one player will, and then the other player will respond to that. Okay, so start with player A. If player B goes left, player A can go up and get 10, or down and get minus 10. So player A is going to go up and get the 10. All right, if player B goes right, player A can go up and get 15, or down and get 15, or down and get 10. So player A is going to go up. So no matter what player B chooses to do, left or right, the best response or the best option is always for player A to go up. So player A is going up no matter what. All right, and then what's player B's option or response to player A? If player A goes up, oh my goodness. If player A goes up, player B can go left. Remember the second number for player B. Player A can go left and get 20, or down. Sorry, I'm messing this up. So if player A goes up, player B can go left and get 20, or right and get 8. Yeah, so player B is going to go left. Okay, that's underlined. And then if player A goes down, player B can go left and get 7, or player B can go right and get 10. 10 is better than 7. Player B is going to do that. All right, so you can see that player B would have a different response given what player A would do, but player A is always going to go up, so we're going to start with that. So if player A always goes up, that means we're stuck with one of these two options, player B. If player A is for sure going up, player B can go left and get 20, or right and get 8, and this is what's going to happen. Okay, so no collusion. That is the outcome, and all you have to do is describe it, which is the strategy. Player A goes up, player B goes left, and the outcomes, player A gets 10, player B gets 20. Okay? What is the likely outcome if player A and player B can reach a collusive agreement. All right, and so this, you're always going to get this question, but sometimes you might get a situation in which they won't reach an agreement because they're only going to make an agreement if it's better for both players to do that. Okay, look at what player B is getting, 20. Now look at all the other options player B could get. 7, 10, or 8. Now, are any of those situations better than the current situation? No. So player B has no incentive to make an agreement and isn't going to make an agreement because player B is already getting the best possible outcome it can possibly get. So player A might like to make an agreement, but player B is not going to because this is the best outcome for player B, no agreement. So look at the other options for both players, and you see here that player A and player B would not reach a collusive agreement because player B is already getting the highest payout possible of 20, and therefore no incentive for player B to make any agreement. All right, and then C, there might be a temptation to cheat on the collusive agreement. What's the likely outcome if player A cheats? Now again, if there's no agreement, just say without a collusive agreement, player A cannot cheat, or there's no collusive agreement, so just this will be the question, but if there's no agreement, then no player is cheating, and just say as much. All right, and then the second game theory, there'll be 2 game theory ones. One where you're given the little picture. All right, and you just got to answer the questions. And the second one, you got to draw the thing or do it in Excel and then answer the same questions like you did in the homework assignment. All right. Assume this is parts D, E, F, and G for question 2. Still question 2. Assume Toyota and Hyundai play the following simultaneous move game. Toyota has 2 pricing options for its 2019 Prius, and Hyundai has 2 pricing options for its 2019 Ioniq. Both Toyota and Hyundai can either price their new hybrid vehicles at $20,000 or they can price them at $25,000. Those are the options. Now, this is a situation where they're both selling pretty much the same type of good, but you'll see that if they can both agree to price higher, they both get higher profits because the consumer has no choice but to pay the higher price. So if both price at $20,000, each earns profits of $3 million. If both price at $25,000, each earns profits of $4 million. And if one prices at $2,000 and one prices at $25,000, the company that prices it lower at $20,000 earns $5 million, and the company that prices at $25,000 gets only $1 million. So if the other company can cheat and get the lower price to the customers, they'll get a majority of the customers if they can cheat on the agreement. All right, so part D, one of the most important parts, is make sure you can reproduce the game tree. So it said, here's Hyundai, here's Toyota, they can both price at $25,000 or $20,000. And it said, if they both price at $20,000, they both get $3 million. If they both price at $25,000, they both get $4 million. And if one prices at $25,000, the other prices at $20,000, the lower pricer, $20,000, gets $5 million. And the higher pricer gets $1 million. All right, so first just draw that. And then part E, assuming no collusion between Toyota and Hyundai, what is the likely outcome? List the strategies and the payouts. Okay, so same thing. Look for the best response of each company, and then you could probably determine the outcome. Okay, start with Toyota responding to Hyundai. If Hyundai prices at 20,000, Toyota could price 20,000 to get 3, or 25,000 to get 1. They're going to price at 20,000. If Hyundai prices at 25,000, Toyota can price at 20,000 and get 5, or 25,000 and get 4. They're going to price at 20,000. So no matter what, Toyota's pricing at 20,000. Okay, you can probably guess that it's the same for Hyundai, but let's do it anyways. If Toyota prices at 20,000, Hyundai can price at 20,000 and get 3, or 25,000 and get 1. They're going to price at 20,000 and get 3 million. If Toyota prices at 25,000, Hyundai could price at 20,000 and get 5, or 25,000 and get 4. So again, they're going to price at 20,000, and we've determined that they're both always going to price at 20,000. Okay, without an agreement. So that means this is the outcome. All right, so list the outcome. No collusion. Strategies and payouts. Strategies are Toyota prices at 20,000, Hyundai prices at 20,000. Toyota gets 3 million, Hyundai gets 3 million. Okay, what is, part F, what is the likely outcome if Toyota and Hyundai can reach a collusive agreement? All right, so you can start with this one. So this is where they're currently at, and you can look around and see, is there a spot which they can both be better off? Yeah, there is right here. So if they can both agree to price at 25,000, they both get an extra million, and that's what they'd like to do is an agreement. Okay, see that? If they can both agree on that, then they both get the extra million. So Toyota prices at 25,000, Hyundai prices at 25,000, and they both get 4 million if they reach the agreement. Okay, part G, there might be a temptation to cheat on the collusive agreement. What is the likely outcome if Toyota cheats? Okay, so basically this was no collusion. That's collusion. All right, and if by definition, if Toyota cheats, that means they're not sticking to their agreement at 25,000. They're cheating and undercutting at 20,000. So this is the cheating part. All right, so if Toyota cheats, that means we're here. Where Toyota didn't keep up the agreement, they undercut at 20,000 and got most of the customers, and this is the outcome. This is the cheating outcome. Where Toyota now prices at 20,000, they cheated. Hyundai stuck with the agreement, 25,000, and the cheating outcome for Toyota is they get 5 million, and Hyundai gets 1 million. All right. So the first part, draw the payoff matrix. The second part, just determine where they both agree upon if they couldn't reach an agreement. The next one, if they can reach agreement, if they can both be better off, what is it? And then what if is there an incentive for one of them to cheat on the agreement? If so, what is that outcome? Okay. Questions on this on this one, the game theory? All right. Well, the last one, number 3, is our favorite, the specialization in trade from chapter 16. All right, so let's go through another example of this one. And again, I think this is, it seems like this is the most challenging question. So if there's any questions on this one, then let me know because I think that I think you guys will be fine on it. But I think this seems like the most difficult homework based on the 3 questions. So let's go through this one. All right, so here we go. Here's an example, and so question 3 is going to be another one from chapter 16, specialization in trade. All right, so we're getting lots of examples. Following hypothetical production possibilities tables are for Hawaii and Papua New Guinea. I said that right. So assume that before specialization in trade, the optimal product mix for Hawaii is alternative B, and for New Guinea, it's alternative U. Okay, so these are the production possibilities alternatives for Hawaii. Okay, so any of these can be produced. Point A is zero marlins, 500 coconuts, B 100 and 400, and so on. So these are all the options A, B, C, D, and E that Hawaii can produce before specialization in trade. All right, for P and G, we got these production alternatives, R, S, T, U, V, and W, where they can produce, there's all coconuts, which is 100, all marlins, which is 50, and then any of these combinations in between. And you'll see that the cost comparisons are different, but they both should give you a nice linear curve you can graph. All right, so draw the production possibilities curves for Hawaii and PNG, including the optimal product mix before specialization in trade. All right, so again, I did this in Excel. All right, so all you have to do, if you want to do this in Excel, is just put a table, reproduce the table with all the options A, B, C, D, E, F, and then just make a little line graph for that. So again, you can do this in Excel. You can do this on a piece of graphing paper, whatever is easier. All you're doing is plotting these points and then drawing a line through them. So you're just connecting the dots, basically. All right, so there's point A, 100 and 500. I mean 0 and 500. There's point B, 1 and 400, and points C, D, E, and F, according to this table. And it said that before specialization in trade, the optimal product mix for Hawaii is alternative B, okay, which is 1 and 400, which is right there. I just made a little highlight. So they're starting at B, and we need that reference when we do the gains from specialization in trade. So just plot the points, draw a line through them. That's the production possibilities curve. And Hawaii is starting here at point B. All right, so for P and G, these are the alternatives for them. So I just put those points on a graph and drew a line through those. All right, so there's point R, 0 marlins, 100 coconuts. Here's point S, 10 marlins and 80 coconuts, just putting points, and then draw the line through those, and it says that P&G starts at alternative U, which is 30 marlins and 40 coconuts. So they're going to start here, 30 marlins and 40 coconuts. Okay, so part A is just plot the points, draw the production possibilities curve, and then identify the initial spot, which is just given in the question. All right, part B. Are comparative cost conditions such that Hawaii and P&G should specialize? And they're going to be, or else there wouldn't be a question, but if so, what product should each produce? So let's identify the opportunity cost for each good for each product. Okay, so for marlins, for Hawaii, just look at the table and it's going to be the same trade-off or domestic opportunity cost no matter what if you go from one point to the next. So if they produce a marlin, they give up 100 coconuts, right? They produce another marlin, they give up 100 coconuts. So one marlin equals negative 100 coconuts. Okay, what about for P&G? P&G for marlins, and this is every time they produce 10, they lose 20 coconuts. So plus 10 minus 20, plus 10 minus 20. So 10 coconuts equals minus 20, 10 marlins equals minus 20 coconuts. And to put that into terms of just one marlin, divide by 10, and you get one marlin is equivalent to minus 2 coconuts for P&G. All right, so once you got them in terms of one marlin equals, and then one marlin equals, you see that the country that has the lowest domestic opportunity cost, who gives up less, is going to specialize. So who has the comparative advantage? Every time Hawaii produces a marlin, they give up 100 coconuts. That's a ton of coconuts. And every time P&G produces a marlin, they only give up 2. So clearly they're giving up less, and they have a clear competitive advantage, P&G, in producing coconuts, producing marlins, because they're giving up less. So P&G has a comparative advantage and should specialize in producing marlins. All right, so it's whoever's giving up less. All right, so Hawaii gives up 100 coconuts. P&G gives up minus 2. This is clearly a better give up. They're giving up less, so they should specialize. Okay. What about for coconuts? Okay, Hawaii. Every time they produce 100 coconuts, they give up one marlin. So plus 100 minus 1. So start with 100 coconuts equals minus 1 marlin. And to get that into terms of one coconut equals, divide by 100, and you see that one coconut, they give up 1/100th of a marlin. Okay, what about for PNG? Every time they produce 20 coconuts, they give up 10 marlins. So plus 10 minus 20, plus 10, I mean, sorry, plus 20 minus 10. So 20 coconuts equals minus 10 marlins. Okay, and to get that into terms of one coconut equals, divide by 20, and you get one coconut equals negative 10 over 20, which is negative 1/2 marlin. All right, so who has a comparative advantage? Who gives up less? PNG gives up a half a marlin. Hawaii only gives up 1/100th of a marlin, so they have a clear comparative advantage. And Hawaii has a lower domestic opportunity cost. They have a comparative advantage and should specialize in producing coconuts. So we know now that Hawaii should produce only coconuts and PNG should produce only marlins. C. What is the total gain in both marlins and coconuts that would result from such specialization? Okay. So start with outputs before specialization, which is just the initial given points. We know that Hawaii starts here, 401, and we know that PNG starts here, 40 and 30. So start with those, and then move on to what they specialize in, and then what's the total gain in both goods for if you add the two countries together. Okay, so this is given. Hawaii starts with 1 marlin and 400 coconuts, and this is given. PNG starts with 30 marlins and 40 coconuts. So we determine that PNG is going to specialize in producing marlins. That means they're not going to produce any coconuts, and if they do that, they produce all the possible marlins. That's 50. So specializing in marlin production for Papua New Guinea is point W, which is 50 and 0. And we also determined that Hawaii is going to specialize in producing coconuts. They're going to produce no marlins and all the possible coconuts they can, which is exactly points A, 0 and 500. Okay, so these are the outputs after specialization. Column 2. So what you're trying to get is the total gain in both coconuts and marlin. So after specialization, we now have 50 total. Originally, we had 30 plus 1, which is 31. Okay, all the marlins combined before. So the total gain is the difference, 50 minus 31, which we gain as a total gain of marlins between both countries, 19 marlins. And how much do we gain in coconuts? Okay, after specialization, there's 500. Before, we had 400 plus 40, which is 440. So what's the difference? What's the gain? Total gain is 500 minus 440. We gain 60 coconuts. So just by specializing as an aggregate, okay, we gain 19 marlins and we gain 60 coconuts. So, okay, everybody good so far with this example? Okay, let's keep going here. Okay, so we're back to determining the limits, right? So this is the same concept we went over by request for your homework chapter 16. Let's apply the logic again. So again, I think this part D is one of the more difficult parts, but with enough practice, I think we'll get it. So let's start with make the statement of what each country specializes in, and then start with their domestic exchange rate, and let's show that they have to beat that in a trade. So first thing is P&G is going to specialize in producing marlins. So if that's the case, their original trade-off, their domestic opportunity cost was 1 marlin equals minus 2 coconuts. So if they're going to specialize in trade, right, the original trade-off was -1 for -2. So in a trade, they have to get better than that. They have to get more than 2. Okay, so start with P&G, who's going to specialize in marlins, and start with their domestic opportunity costs for marlins, which is the good they're specializing in. So start with this. P&G has got to get better than 1 marlin equals -2 coconuts. All right, and then let's make the other statement for Hawaii, who's going to specialize in coconuts. Okay, Hawaii is going to specialize in coconuts, and just write the statement for their domestic opportunity cost for coconuts, which is this. So they got to get better than 1/100th of a marlin in a trade. Otherwise, they wouldn't be better off trading. So start with this statement for the coconut good, which they're specializing in. So just start with their domestic opportunity costs, and we'll go from there. So Hawaii has to get better than this. All right. So we started where P&G is going to specialize in marlins, and they got to get better than their domestic opportunity costs in a trade. Hawaii is going to specialize in coconuts, and they got to get better than their domestic opportunity costs in a trade. Now, the only thing you have to do next is put these both in terms of one on the same good. So I put them in terms of 1 marlin. So this one's already in that. 1 marlin equals -2 coconuts. Now put this one in terms of 1 marlin equals. To do that, just multiply both sides by 100, and you'll get 1 marlin equals -100 coconuts. So we have a huge range of outcomes where as long as the trade is 1 marlin equals somewhere between 2 and 100, the trade is good for both countries. All right, and again, just if you wanted to, just to show you, there's another way to state the limits, which is in terms of 1 coconut equals. So let me do that just to be thorough. Okay, so instead put the trade in terms of coconuts. Start with the one that's already in that. 1 coconut equals -1/100 marlin. All right, and then put the other one in terms of 1 coconut. Okay, that one. So to put that one in terms of 1 coconut, just divide by 2. That means that 1 coconut equals -1/2 marlin. All right, so you should be able to see that this okay, so you should see that this is the same exact thing as this, except this one is in terms of one marlin, and this one's in terms of one coconut. So you can just see like if you put this in terms of one coconut, you get one coconut equals a half marlin, and this one you divide by 100, you get this. So either one of these, this green statement or this blue statement, it's the same exact thing. They're both correct, and you can express it either way. So this one is the same as this one. Either one is right. All right, so that's part D. All right, so part E is the main determinant of what the gains from trade are. So let's again for this one, just put the columns just like I have. So you're going to have the country. Column 1 is going to be outputs before specialization. Column 2 is going to be outputs after specialization. You've already got these two parts. And then you add these three parts. What's the trade? Column 3 is amounts traded. Column 4 is the outputs available after trade. And then column 5 is the gain from specialization and trade. So I'd recommend just write columns 1, 2, 3, 4, and 5 in your chart, and just set those up before you start to do this part, and then just go from 1, 2, 3, 4, 5. All right, so we've already done up to column 2, right? We've done this, we've done this. Okay, so we're starting here. Well, first let's see what the trade is. So let's suppose the actual terms of trade are 1 marlin for 50 coconuts. So that's well within the limits. All right, so that goes right, it's bigger than this and less than that. So that's going to benefit both countries. They're both going to be more than happy to do that trade, as long as it's in between the limits. And that 2 marlins are exchanged for 100 coconuts. So the trade is 1 for 50, but the trade terms are 1 for 50. The actual trade is 2 marlins for 100 coconuts. So what are the gains from specialization and trade for both Hawaii and PNG? So we already got this part. This is given. All right, so it's given that Hawaii starts at 1 marlin, 400 coconuts. It's given that PNG starts at 30 marlins and 40 coconuts. We know that Hawaii is going to specialize in coconuts, which means they're going to produce all the coconuts they can, 50 coconuts and 0 marlins. And we know that PNG is going to specialize in marlins. They're going to produce all the marlins they can, 50 marlins and 0 coconuts. So we've already got to this point. Now, let's do the trade. So the trade is given 2 marlins are exchanged for 100 coconuts. So whoever has the coconuts is going to trade for marlins, and whoever has the marlins is going to trade for coconuts. All right, so that means that Hawaii had the coconuts. They're going to trade the 100 marlins, and they're going to gain the 2 coconuts. So they get a plus 2 marlins, and they lose 100 coconuts. All right, PNG has the marlins, so they're going to trade the marlins for the coconuts. So they're going to trade away the 2 marlins, and they're going to gain the 100 coconuts. So this is the trade, and just stated in terms of a plus minus for both. All right, so whoever has the coconuts loses coconuts and gets the marlins. Whoever has the marlins loses the marlins and gets the coconuts. All right, so this is the trade represented in terms of both countries. All right, so after you state the trade, what's the outputs available after the trade? So here's the specialization, and here's the trade. So 0 marlins plus 2 marlins is just 2 marlins. 500 coconuts minus 100 coconuts is 400 coconuts. So after the trade, Hawaii has 2 marlins and 400 coconuts. Now for PNG, Okay, this is specialization, and this is the trade. So 50 marlins minus 2 marlins is 48 marlins. And 0 coconuts plus 100 coconuts is 100 coconuts. So this is their output after the trade. And now let's see what the main point is. What's the gain from specialization and trade for both countries? Okay, and this is column 4 minus column 1. So let's see. After specialization and trade, Hawaii had 2 marlins. They started with 1. So 2 minus 1, they gained a marlin. And before specialization and trade, they had 400 coconuts. They still have 400 coconuts, so they gained nothing there. But they gained 1 marlin in the trade. What about PNG? So they started with 30 marlins. They now have 48. So that's a gain, a plus of 18. And they started with 40 coconuts. Now they have 100, so that's a gain of 60. All right, so if you do it like the columns, then column 5 should be column 4 minus column 1. All right, 2 minus 1 is 1. 400 minus 400 is 0. 48 minus 30 is 18, and 100 minus 40 is 60. So you might not always get that both countries gain in both goods, but no country's gonna lose something. They're just gonna gain. So after the specialization in trade, Hawaii's got a plus 1 in marlins, same coconuts. PNG has a plus 18 marlins and a plus 60 coconuts. So this column here is what you're trying to get to for part E. Oops. Okay. Question. So part E is pretty much, or not pretty part E is a big part of this type of problem. So any questions on what to do here, how to set up the chart, and how to get the gains from specialization and trade? Okay, so the question is, how did you determine amounts traded again? Okay, so that's given. So in the beginning of part E, it'll tell you the actual trade. So it'll tell you the terms of the trade, which you'll need for the next part, and then the actual trade. So the actual trade is 2 marlins for 100 coconuts. So that's going to be given, but you have to figure out who trades and who gets. So basically, whoever specialized in coconuts is going to get the 2 marlins. Whoever specialized in marlins is going to get the 100 coconuts, right? So just take this statement and apply it from both countries, right? So Hawaii specializes in coconuts, which means they start with 500 coconuts and 0 marlins. So they're going to get the 2 marlins and lose the 100 coconuts. Okay, and then so PNG starts with 50 marlins and has no coconuts. So they're going to trade away the 2 marlins and gain the 100 coconuts. So just take the given trade and represent it in terms of both countries, in terms of what they're getting and what they're giving away, right? Okay, so any more questions on the table here? How we get all these values? Okay, then part F, the last part is to redraw the new graph with all the possibilities they can get from the trade. All right, so this part is to start with their specialization outcomes, and then show all the possibilities they can get at the current trade terms they agreed upon. So the trade terms are 1 marlin for 50 coconuts. So what you're representing here is the countries that specialize can keep a certain amount and then trade the rest at this exchange rate. All right, and it's always a fixed exchange rate, and so it's going to be, you're going to start with the specialized axes and show all the possibilities they can get at a gain from trade. So as long as they make any trade, they're going to gain. Okay, so let's start. Let's go to my spreadsheet to show how we got this. All right, so let's. Okay, so this is Hawaii. All right, so start with their original outputs, the table that was given. That's this. Okay, and then start with the good they're going to specialize in, and just rewrite that same axis. So Hawaii is going to specialize in coconuts, right? So we know that. So just take this, the same axes, and put it right here. All right. So take the good they specialize in. This is the same as this. All right. All those values are exactly the same. So just this is this. All right. And the reason is because they can't gain any coconuts because they're the only country now producing coconuts. So they can't gain any coconuts initially. Now, all the A prime, B prime, and C prime show the possible marlins they can get in a trade if they trade the coconuts that are not shown here. So if they're specializing in coconuts, they do this. Okay, specialization for Hawaii is 500 coconuts and 0 marlins. All right. So what they can do is they start with the 500, and all the other points represent the coconuts they still have and what they got in a trade. All right. So if they specialize and produce 500 coconuts and don't trade any, then this is what they have. Now B prime represents they keep 400 coconuts and they trade 100 marlins. I mean, they trade 100 coconuts. And now the exchange rate is 1 marlin for 50 coconuts, which is another way of saying, I'll rewrite it here. Okay, so this is the terms of trade. 1 marlin equals 50 coconuts. And if you express that in terms of coconuts, just divide by 50, and you'll see that 1 marlin for 50 coconuts is the same as 1 coconut for 1/50th of a marlin. So this is the same as this. All right, represented just to flip it around. All right, so the trade is 1 marlin for 50 coconuts, or 1 coconut for 1/50th of a marlin. This is the same exact thing. So that means if Hawaii trades any coconuts, they trade them at this exchange rate. All right, and if they trade 2 coconuts, they get a marlin. Okay, so see how I represented the trade here? Just divided by 50 because any of these, any traded coconut gives them 1/50th of a marlin in return. All right, so if they keep 400 coconuts, that means they must have traded 100. And 100 times, or 100 divided by 50 is 2. Okay, so if they trade 100 coconuts at 1 for 1/50th, that means what they get back is two marlins. Here, so you see how the formula is the same? It's always what they traded away divided by 50. So any of those traded coconuts give them a 50th of a marlin, so just divide by 50 to see the final result from the trade. So here, so let's start here. So here they have 500 coconuts. They don't trade any, so this is the outcome. Here, they keep 400 coconuts. They trade 100, and they get two marlins in return. Here, they keep 300 coconuts. They trade 200 coconuts for 4 marlins. Here, they keep 200, and they trade 300 coconuts for 6 marlins. And here they keep 100, and they trade 400 coconuts for 8 marlins. Here they trade them all. If they trade 500 divided by 50, that's 10 marlins. You can see that these are all situations where they're better off from initial, where this was 0 and 50. This was 1 and 400, now it's 2 and 400. This was 2 and 300, now it's 4. So all their marlin possibilities have doubled. Okay, and so you should get a constant increase here, but you see that the formula I wrote is just what they have left after they trade, and then what they get in the trade. Then we'll do PNG in a minute, but this, so if you graph the new outcome with the possibilities of trade, you get this. And you see that, they start at A, and all of these outcomes are better than their initial situation. So any trade they make, B prime, C prime, D prime, E prime, F prime, they're better off than what they were. So see how this starts at 500, but they can get up to 10 marlins in a trade they agreed upon. So this green line is better off. It kind of goes like this. All right, let's do the new production possibilities curve with trade for PNG. So they're going to start with the marlins because they're going to specialize in marlins. So just take this and put it right here. All right, so the marlin values stay the same. Start with that because that's what they're specializing in. That they can't gain any marlins in the trade. They can only gain coconuts. Now, any marlin they trade, they get back in a trade 50 coconuts. So this is the trade. It's a little bit easier when you're doing it 1 for instead of 1 equals 1/50th, but you have to represent it in the same terms. So the country trading marlins is trading 1 marlin for 50 coconuts, and they can always get that trade. So those are all the possibilities that PNG is going to get when they trade a marlin, and they get back 50 coconuts in return for each marlin traded. All right, so I think this one's a little easier because you're not dividing by 50. So point W prime should be the same because they didn't trade any marlins. All right, point V prime is they kept 40 marlins and they traded 10. And each traded marlin gives them 50 50 coconuts. So 10 times 50 is 500. Right? So here's the exchange rate. Okay, what they have left is 40, and what they traded away is 10. So 10 times 50 is 500, because they're trading one marlin for each marlin gives them 50 coconuts. All right, here, U prime, they kept 30 marlins. They traded 20. 20 times 50 is 1,000. Right? That's the trade they agreed upon. Each marlin gives them 50 coconuts. Here, they kept 20. They traded 30. 30 times 50 is 1,500. Here, they kept 10. They must have traded 40. 40 times 50 is 2,000. And they could possibly get up to 2,500 coconuts in a trade if they trade them all. So they trade all the marlins here at 1 to 50. 50 times 2,500 is 2,500. Okay, so if you graph that curve, that shows all the potential gains they can gain in coconuts by trading with Hawaii. So see how the initial one, it's 50. These are the same because they're specializing in that. And then initially they can get up to 100. Now with trade, they can get up to 2,500. So all of these outcomes, B prime, U prime, T prime, are all better than their initial situation. And they all show that any trade at that rate will give them a better outcome than the initial no trade, no specialization. All right, so there's that one showing that, again, here's Hawaii's specializing in coconuts. And then these are all the outcomes they can get in a trade for marlins at one coconut equals a 50th of a marlin. And then this one is showing that P&G is going to specialize in marlins. Okay, and then these are all the possible trades of coconuts they can get in a trade with Hawaii, which is what they're getting for one marlin equals 50 coconuts. Okay, so questions on how I got the final graphs here? All right. Well, okay, so that's the review, and let me. So I'm going to show you guys. Well, actually, I got to post it first. So I'm going to post um, the midterm, and I'm going to post a couple extra credit questions, and we'll talk about those things in a second. So just give me a minute to post. Okay, so if you go to the midterm 2 fall 2020 section on Blackboard, all right, so here's here's the practice exam we just went through in my solutions. So you got that as a reference. And then you should see here midterm 2 fall 2020. I posted a Word document and a PDF. They're both the same exact thing. Whichever you want to use is fine. Let me pull up the PDF. Okay. So here's your midterm 2. It tells you the due date, which is next Wednesday. All right, so it's due by next Wednesday, November 11th. And you just email it to me. So email me your answer sheet as a PDF or Word document if you can do that by next Wednesday. All right, and you should see the same type of questions that we're familiar with. You got the first questions on the markets and profit max. You state the price, the quantity, the profit, and then what type of market it is. For these, there's two here. So do this one for that, and then do this one. All right, this one you have you have two game theory ones. One where you're given the picture. You just got to do collusion, um, no collusion, collusion, and then if one of the players cheats, okay, if they reach an agreement. Then this one, you're going to read the little word problem, draw the payoff matrix, and then do collusion, do no collusion. Can they reach a collusive agreement? If so, describe it. And then what if one of the players cheats? Okay. And then you got another one on specialization and trade. All right. So you got one country, Snoop. You got one country, Dog, and they're trading gin and juice. So these are the production possibilities curves there. And I think I made it easy for the trade. They're going to trade one for one. So that should make your trade moves a lot easier. All right, so you got to do the whole problem, but just know that the actual terms of trade are one bottle of gin for one bottle of juice, so it's one for one. So that should make the new graph part a lot easier to do, but you still got to do the whole process. Okay, so questions on any of these three problems on your midterm? What do you have to do for these? All right, and then and then everyone's good on getting in the chapter 16 homework today. Okay, and then all right, so before we go, I tried to make some extra credit questions you can do if you want, and these are based on some of the current propositions that just happened in California. So the ones I found most relevant to economics are, so let's open up this one. All right, so midterm 2, fall 2020, you got the exam, and then if you want to do, you can get some extra credit points. Open this up. All right, so here you go. I created some questions based on some of the current California propositions. So this, you can earn up to 10 points on midterm 1 or midterm 2. So if you, so that way it gives you some flexibility. If you missed any, you can spread them out. So total, if you need points on midterm 1 or midterm 2, you can use this you can do this, and I can give you points on either one. It doesn't. They're both worth the same, so I'll just apply the points accordingly if you do it. And this, just email your. It's due the same time as the midterm, so if you do the extra credit, just email a separate answer key, or you can add it to the same one by next Wednesday as well. So this is just like an extension of the midterm. Okay, so I put one question on. There was a rent control proposition that was proposed, and so read the little description. And I found these little. For all the California propositions, there was a nice like web page that explained all the propositions in like a minute. And so I watched all these before when I was voting for them. Okay, so for rent control description, read the little box, then just watch this video. It's literally like it's like a minute, so it's pretty useful explaining what's going on. So watch the quick video, and then answer the questions. So if you want to do the extra credit, part A, would Prop 21, which is just assume it's a rent control situation, would that lead to a price ceiling or a price floor? B, draw the appropriate supply and demand graph with the government price restriction. So we did this same exact thing in chapter 3, right? So you should have that in your lecture slides and your notes. And then C, would Prop 21 lead to a surplus or a shortage of housing rental units? And then D, did this proposition pass or fail in California? So really the only thing you have to do that's would take any time is draw the graph. Okay, so if you recall this, just draw a supply and demand graph with the appropriate price restriction, if this is a price floor or a price ceiling, and how that would affect the market. And then all the other questions are just like one word statements. So is it a price floor or a price ceiling? Would it lead to a shortage or a surplus? And then did it pass or did it not? All right, and then the second one is on Prop 22, which was a big one in California. This was on changing the rules for app-based drivers and like Uber and Lyft, and if they should be. There was this AB5 reclassified them as they had to all be normal employees and get minimum wage, workers' comp, and overtime. And Prop 22, if it passed, would overturn that and go back to what it was before, which was to reclassify them as independent contractors. Okay, so read that little description. You can watch the video, it's like a minute. And then just some questions that go along with this, because I thought it was kind of relevant to this class, is part A, assume Prop 22 failed, right, which means the laws were left changed, which meant that Uber and Lyft must now pay all employees minimum wage, workers' comp, and overtime. So what happened here is California passed this law, AB 55, making the workers have to be reclassified. But all the apps like Uber and Lyft refused to do it, and they put this proposition on the ballot to overturn it officially. So if this didn't pass, which meant that they had to obey the rules and classify all the workers as full-time employees and pay the minimum wage, workers' comp, and overtime pay. So if that's the case, assume the number of employees is constant and there's an added cost. In other words, the cost per Uber Lyft worker has increased. The questions are, who is likely to bear some of the added cost? All right, so if there's an increase in per worker cost, who's going to pay for that cost? Is it going to be just Uber, or are the customers going to pay some higher prices? And then the second part, if Prop 22 failed, would Uber Lyft prices likely rise or fall after that? So you could probably see if this passed or failed. I'm pretty sure that this one, actually, I know that this one failed. I know that this one passed. So, but if it had failed, is it likely that like ride prices on Uber Lyft would increase or decrease? Okay. Then B, assume Uber Lyft companies and everyone else are now required to pay all workers overtime wages if they exceed 40 hours per week instead of the fixed per payment system that they had initially. So initially, uh, it is that they get a percentage of each ride, right? So if that was changed and they had to now pay overtime based on going over 40 hours, the question is, would Uber Lyft be incentivized to pay overtime wages or not? And then C, assume overtime is implemented. Which is the more likely outcome? So outcome one, with overtime, you have more Uber Lyft employees than before, but they all work less than 40 hours per week, so they're under that minimum wage mark. Or is it more likely that there's less of them, they work longer hours, and there's a lot of workers exceed overtime? They're just determine which of those two statements is more likely if Uber and Lyft had to all of a sudden pay overtime. And then did this pass or fail? All right. So I mean, these questions are the wording is longer than probably doing the questions. So if you want to, I mean, if you want to do these, then these will be extra crediting it. You don't have to get. I mean, there's no 100% right or wrong answer except really for this. Um, but if you make a good attempt on these two, you can get 10 points on the midterm one or midterm two. And it's I thought it was nice to have something that was relevant in today's election. Okay, and then if he voted for or against these propositions, you can see how that might have affected kind of in a simple microeconomic sense. But yeah, so these are a little bit different. But if you make a good attempt on these, it really shouldn't take too long. You can get 10 points on the midterm, and it might be a little fun to just do something different than the normal questions. So, questions on what I want you to do here for the extra credit, if you want to do it. Okay, well, I mean, anyway, if you have some extra time, I'd recommend doing it just in case if you miss some of the questions for the big gains from trade problem. This will make up for that, and it can't hurt. I mean, you can't lose points. So um, yeah, try to make a good attempt at this, and I'm trying to give everyone 10 points as long as you try to do it. So there's that, and yeah, so all right, so chapter 16 homework is due today, yeah, and midterm two is due in a week via email. So there's the midterm, and then you get these as a reference, and then if you want to do the quick extra credits, send those along with the midterm or after by next Wednesday, and you get that. So I think that's all I have. Everybody good? Any questions on any of this stuff? Okay. If you have questions on any of those things. But yeah, so you got the midterm, you got the chapter 16 homework, and you got the extra credit. And I will see everyone next Wednesday, same time. And thanks everyone for participating, and have a good rest of your week.
Thank you.
Thank you.
Have a good night.
Have a good night.
You too. Thanks.